Driving circularity, creating a data space for sustainable battery use. Let's first clarify why a data space is even necessary. Imagine buying an electrical car, sustainable, efficient and forward-looking. But what happens if the battery ages or fails, making the car unusable? This is where our project steps in, enabling resource reuse and systematic data exchange across a connected value chain. In the automotive sector, many actors must interact to enable a circular economy. Users, suppliers, manufacturers, repairers, dismantlers, remanufacturers, recyclers, and the repurpose market. Each has different roles, requirements, and needs, all of which are addressed through our data space. To demonstrate a closed battery loop, we modeled two example scenarios: lifetime extension and second life application. Let's now take a closer look at the second life scenario. The journey begins with the user. When an issue arises, the vehicle is brought to a repair shop. The repairer reads and updates battery data in the data space. These changes are also visible for the user. If the battery is no longer suitable for the automotive use, it is passed on to the dismantler. This decision is made by the repairer through the information from our data space. Based on construction data stored in the data space, the dismantler safely disassembles the battery. The extracted cells can then be sold via the repurpose market, for example, for use in a stationary storage system. Now let's look at the actual data stored in the data space. Together they form a digital twin of the battery, reflecting all information about the battery such as usage history, performance and more. This data is organized into data products, like folders or submodels, each covering a specific domain, such as product and component quality assessment. Inside these submodels, individual data points are stored, for example, the battery's state of health. One of the main challenges was to ensure that all data is stored decentrally and federated at each actor's location, not centrally at the manufacturer. It was also crucial to enforce strict access control, so each actor can only read and edit the data relevant to them. Let's look how this works from the repairer's perspective. They log in via KeyCloud with role-based access control. Then the repairer can read and edit data points. For example, in the product and component quality assessment submodel, such as the state of health. However, in the disassembly and modularity submodel, they can only read. Any attempt to edit the data point repair manual will not be updated. So what impact can our data space have in the future? We see three core improvements. Sustainability. Batteries are used longer and raw materials are reused across applications. Traceability. All battery data is stored and updated in one place, enabling complete lifecycle transparency. Transparency. Each actor knows who can access which data. That is strengthening trust and collaboration across the value chain. Together, these improvements create the foundation for a functioning circular economy.